Hello guys, again to my channel. We continue talking about modern control. Before we study another topics, we will finish the last course talking about controllability matrix. After we find the controllability matrix, what we do, we repeat enter again the data system. The syntax of the controllability matrix in the Matlab, it is a function needs two inputs and give us one output. Two inputs. The first one is the system matrix A, square matrix. For example, in this example, this A, it is equal to 1, first row, 1, 2, 4, second row, 1, 3, minus 1, third row, minus 2, 10, 5. This is a matrix A, called the system matrix. This is a delimiter. I use this for my idea is I use this. Anyone you can change it, star or double star or anything, any character or letter like that, or a word like that, as you like. I use 2 points. Now enter the second matrix, B, or called the input matrix. It is 3 rows by 1 column. 3 rows by 1 columns. 2 minus 3, 4. That's enough. Now click here on the button controller. This EC here. We will get the matrix. This is the controllability matrix of the system, the last system, the previous system. Now we get the controllability matrix of the system. What we now do with this matrix? Now we calculate the determinant of this matrix. Our system is 3 by 3. Degree of 3 system. Our system has a degree of 3, equal 3. If the system is completely controllable, should be determinant of this matrix. The determinant of controllability matrix should be equal to 3, because the degree of our system is 3. If less, it is that's means this system not completely controllable, or rather than partial controllable system. We go here. Determinant is this AC. This button, determinant, det. To improve the system is completely controllable, there is two things. If the system if the determinant of the system not equal to 0, like this, that means our system is completely controllable. Or the rank of this controllable matrix equal the degree of the system. I repeat system quickly. That is to improve the controllability with determinant or with the rank of the matrix. -1. Physically, what express the controllability matrix? What is the physical meaning? The physical meaning of the controllability matrix, it is the linearity of the variables of the system. If the system all the variables of the system independent, it means controllable, fully controllable. -3, 4. Now we calculate the controllable matrix of the system, of our system. We go here to controllable, push button, and click here. This is our matrix, what we look for. How to know our system is completely controllable or not, or partial, partial controllable. Our system is of degree 3. If the rank of this matrix equals 3, that's ensure our system is completely controllable. We click here on the rank. You see, rank equal 3, and the degree of our system is 3. That means our system is completely controllable. That means our input of the system influence on all the system, internal system of the internal states of the system. Okay, guys. Now we will show you the program or the algorithm of this command control ctrb. It is a Matlab command. I go here. This is a callback, function callback. You see here program in editor. This is a Matlab editor. When I click on the push button ctrb controllable, ctrb will execute. It means execute this function. The first line s equal get handles dot txt1 string. That means s string. That means s contain the contents of our text box. Second line s is equal to string split. I want to split because we have two entries, a and b. This separate a from a and b. See here on type cell. This type string, this C type cell. The third line we convert between the types from the cell to char, because is here, because here is s c is cell 1 by 2. I convert from cell to char with this function cell to char. C2 matrix. This MA1 is char, type char. This also type char. These 5 lines, we use another conversion function from string to double. Here, a new one, a new 2 is double, type double. Here, on this line, we calculate the controllability matrix. You see here, this function accepts 2 inputs and 1 output. This is the syntax of this function. You can't give it 3 inputs. It will be error. Or if you want to try to get 2 inputs, it's also give you an error. You should know this syntax, this form. You should keep in your mind, should keep it like this. After we got the controllable matrix, we change it from, because here it is a double type. The output of a controllable matrix, this function, double type. Here I will change from double to string. This function will do that. Num to string. This is a conversion. Here we calculate the rank of this matrix. Here also change, and this line print the output. This is our output. This is our target. Print output again in the inside the text box called or tagged txt1. In our this is txt1. This is txt1. That's all. That's all of this item. The same thing we discuss about the observability of the system. The observability of the system is concerning with the 2 input, similar 2 input and 1 output. The input of the observability of the system is the system matrix and output matrix, A and C. This is observability. Now this is the first input system matrix. The second matrix for the observability matrix is the matrix called C, or it's express the or called the output matrix. But in this case not vector, not column vector. It is row vector, like this. We change this semicolon. We will change like this. Must be might be that it's blank, or might be comma. It is no problem. But if you put semicolon, it is false. That's common use. And keep our delimiter. It's very important, this character, to separate this matrix and this matrix. And here click here. rather than click on CTRB, controllability matrix, we click here, observability matrix. And we got, that's all, you get it quickly. You see? Our target. So we calculate the observability matrix of the system. How do now how you know if this system completely observable or not? The same thing, the same speech like controllable matrix or controllable system. You can improve by two ways. By determinant, calculate the determinant, or by calculate the rank of the system. Rank of this equation, this matrix. If the rank of this matrix equals 3, that means the system is fully observable. If the rank of the less than 3, it means system not completely observable, or rather than it is partial observable. We calculate the rank, also equal 3. That means that our system is also completely observable. I think it is easy. So why use this interface? Why create this interface? The purpose, as I said, to gain time. If I have matrix, system matrix 100 by 100 or 1000 by 1000 square matrix, 1000, it will calculate the observability or controllability in just in 1 second, very quickly. Just applying this button or this. I think it is now it is clear and obvious. If you have a question, please write to me in the comments, and don't forget to share and subscribe. We will continue in another topics, very important topics in modern control, such as fuzzy logic control, neural networks control, data-driven control. Thank you.